Every year, billions of pencils are produced around the world. Despite being one of the most common tools ever created, few people stop to think about how a pencil is actually made. Whether in classrooms, offices, workshops, or art studios, pencils remain an essential part of everyday life for millions of people. At first glance, a pencil seems incredibly simple. A small wooden body with a graphite core hidden inside. But its story is far more fascinating than most people realize. Long before a pencil reaches a store shelf, its journey begins deep inside carefully managed forests, where the right trees are selected for production. From raw wood and graphite to the finished product we recognize today, every pencil passes through a series of precise manufacturing stages. In this video, we'll follow the complete journey of a pencil and discover how one of the world's most familiar writing tools is made. Not every tree is suitable for making pencils. Manufacturers must carefully choose wood that is strong enough for production, yet soft enough to be sharpened without cracking. For many years, cedar has been one of the most popular choices for pencil manufacturing because of its unique combination of durability, lightweight, and smooth texture. Before any tree is harvested, forestry specialists inspect entire sections of forest to identify trees that meet strict quality standards. The selected trees must grow straight and develop evenly, ensuring the wood can later be cut into precise pencil slats. This careful selection process helps manufacturers produce pencils that are strong, reliable, and comfortable to use. Only after passing these inspections can a tree begin its journey toward becoming a pencil. Once the right trees have been selected, the harvesting process can begin. This marks the first major step in transforming a living tree into a writing tool used by millions of people. Professional forestry crews carefully cut the selected trees using specialized equipment designed to maximize efficiency while minimizing waste. After being cut down, the trees are stripped of their branches and prepared for transportation. At this stage, each tree becomes a valuable source of raw material for future pencil production. The trunks are then cut into large sections known as logs, making them easier to transport and process at industrial facilities. Before leaving the forest, the logs are inspected once again to ensure they meet the quality requirements needed for manufacturing. With the harvesting complete, the logs begin their journey to the sawmills, where the next stage of production will take place. After leaving the forest, the logs are transported to a sawmill, where the transformation from raw timber to pencil material truly begins. As the trucks arrive, the logs are carefully unloaded and sorted according to their size, quality, and condition. This helps ensure a consistent manufacturing process later on. Before any cutting takes place, the outer bark is removed. While bark protects a living tree, it serves no purpose in pencil production and must be stripped away. Once the logs have been cleaned, they are fed into powerful industrial saws capable of cutting large pieces of timber with remarkable precision. The logs are then sliced into wooden boards, creating the first recognizable form of the material that will eventually become pencils. By the end of this stage, the raw logs that once stood in a forest have been transformed into neatly cut lumber, ready for further processing. Although the cedar boards now look ready for production, they still contain a significant amount of moisture. If this moisture remains inside the wood, the finished pencils could warp, crack, or break during use. To prevent these problems, the boards must go through a carefully controlled drying process. This step is essential for producing strong and reliable pencils. The wood is stacked inside large industrial drying kilns, where temperature, airflow, and humidity are closely monitored. Over several days, excess moisture is gradually removed from the boards. Drying the wood too quickly could damage it, so the process must be carefully controlled. As the moisture content decreases, the wood becomes more stable and suitable for precision manufacturing. By the end of this stage, the cedar boards have reached the ideal condition for the next phase of production, where they will be transformed into pencil slats.
With the drying process complete, the cedar boards are finally ready for precision machining. At this point, the wood has the strength and stability needed for accurate manufacturing. The boards are fed into specialized cutting machines that slice them into thin, uniform pieces known as pencil slats. Every slat must meet strict size requirements. Even small variations could affect the quality and appearance of the finished pencil. As the slats move through the production line, advanced equipment checks their dimensions and surface quality to ensure consistency. The smooth surfaces of the slats make them ideal for the next manufacturing stage, where grooves will be added to hold the graphite cores. By the end of this process, the rough lumber from the sawmill has been transformed into precise wooden components that already resemble the foundation of a pencil. Although the wooden slats already resemble the shape of a pencil, an important step is still missing. The graphite core needs a place to sit securely inside the wood. To make this possible, each slat passes through precision milling machines that carve narrow grooves along its entire length. These grooves must be cut with remarkable accuracy. If they are too deep, too shallow, or slightly misaligned, the finished pencil may not perform properly. Modern manufacturing equipment can produce thousands of perfectly matched grooves every hour, ensuring consistency across the entire production line. As the slats move through the machines, their surfaces are carefully shaped and prepared for the graphite cores that will soon be inserted. By the end of this stage, every wooden slat contains a series of perfectly formed channels, ready to receive the writing core that will eventually leave marks on paper. Many people still refer to the writing core of a pencil as lead. But modern pencils contain no lead at all. The material inside is actually a carefully engineered mixture of graphite and clay. The process begins with finely ground graphite, a naturally occurring form of carbon that is responsible for the dark marks a pencil leaves on paper. Manufacturers combine the graphite with clay and water to create a smooth, uniform paste. The exact ratio of graphite to clay determines how soft or hard the finished pencil will be. Once the mixture reaches the proper consistency, it is thoroughly blended to ensure that every particle is evenly distributed throughout the material. The resulting paste must be carefully prepared before it can be shaped into the thin cores that will eventually be placed inside the wooden slats. At this stage, the writing material that gives a pencil its purpose has finally begun to take shape. With the graphite mixture fully prepared, the next step is to transform the soft paste into long, thin cores that can fit inside a pencil. The mixture is forced through specialized extrusion machines that shape it into continuous strands with a precise diameter. As the graphite strands emerge from the equipment, they already resemble the cores found inside finished pencils, although they are still fragile and contain moisture. To prevent damage, the newly formed cores are carefully cut into manageable lengths and placed onto trays for further processing. At this stage, consistency is critical. Every core must have the same thickness to ensure a smooth writing experience and reliable performance. By the end of this process, the graphite mixture has been transformed into hundreds of delicate pencil cores, ready for drying and strengthening. Although the graphite cores now have their final shape, they are still too fragile to be used inside a pencil. At this stage, they contain moisture and can break easily under pressure. To strengthen them, the cores are carefully dried under controlled conditions. This removes excess moisture and prepares them for the next critical step. Once dried, the cores are placed inside specialized industrial kilns and heated to high temperatures. During firing, the graphite and clay particles bond together more tightly, giving the cores the strength needed to withstand sharpening, writing, and everyday use. The temperature and firing time must be carefully controlled. Even small variations can affect the hardness, durability, and writing performance of the finished pencil. By the end of this process, the fragile graphite rods have been transformed into strong and reliable pencil cores, ready to be installed inside the wooden slats. For the first time in the production process, the two main components of a pencil finally come together. The wooden slats prepared earlier are now ready to receive the graphite cores. Each graphite core is carefully placed into the precision-cut grooves that run along the length of the wooden slats. This step requires a high degree of accuracy. The cores must sit perfectly inside the grooves to ensure the finished pencil writes smoothly and remains structurally strong. Modern production lines use automated systems capable of positioning thousands of graphite cores with remarkable precision every hour. Once the cores have been inserted, the slats are carefully inspected to verify that every groove has been filled correctly and that the cores remain perfectly aligned. At this stage, the essential writing component has finally been joined with the wooden body, bringing the pencil one step closer to its final form. With the graphite cores securely positioned inside the grooves, The next step is to enclose them within the wooden body of the pencil. A thin layer of industrial adhesive is carefully applied to the surface of the slats. This adhesive will permanently bond the two wooden halves together. Once the glue has been applied, a second grooved slat is placed on top, creating a sandwich-like structure with the graphite cores sealed inside. The assembled slats are then pressed together under controlled pressure to ensure a strong and uniform bond across the entire length of the wood. As the adhesive cures, the separate components become a single solid piece, with the graphite cores safely protected inside the wooden body. By the end of this stage, the pencil finally begins to resemble its familiar form, although several important manufacturing steps still remain. At this stage, the large wooden blocks already contain the graphite cores, but they still do not look like individual pencils. Several pencils are still connected within each block. To create their final shape, the blocks pass through precision milling machines designed to carve multiple pencils at the same time. As the machines cut through the wood, the familiar outlines of pencils begin to appear. Depending on the design, the pencils may be shaped into round, hexagonal, or triangular profiles. The shaping process must be extremely accurate. Every pencil needs consistent dimensions to ensure comfort, balance, and reliable performance. After machining, the individual pencils remain attached to one another in long wooden strips, making them easier to handle during the next production stages. For the first time in the manufacturing process, the product now clearly resembles the pencils we recognize and use every day. Although the pencils now have their final shape, their surfaces are not yet ready for finishing. Small imperfections left behind by the shaping process must first be removed. To create a smooth and comfortable surface, the pencils pass through a series of sanding machines that carefully polish the wood. As the abrasive belts move across the pencils, rough edges and tiny surface defects gradually disappear. This step is important not only for appearance but also for comfort. A smooth pencil feels better in the hand and provides a higher quality writing experience. After sanding, the pencils are thoroughly cleaned to remove dust and fine wood particles that could interfere with the finishing process. By the end of this stage, the pencils have a clean, uniform surface and are finally ready to receive the layers of paint that will give them their familiar appearance. With the surface preparation complete, the pencils are finally ready for one of the most recognizable stages of production: painting. Although many people associate pencils with their familiar yellow color, pencils can be manufactured in a wide variety of colors and finishes depending on the brand and intended use. The pencils move through automated painting systems where thin, even layers of paint are applied to the wooden surface. Rather than applying a single thick coat, manufacturers typically use multiple layers. This creates a smoother finish, improves durability, and gives the pencils a more professional appearance. Between each coating stage, the pencils are carefully dried to ensure the paint cures properly and bonds securely to the wood. By the end of this process, the plain wooden pencils have been transformed into colorful finished products, instantly recognizable to people around the world. At this point, the pencils have been shaped, painted, and dried. However, they are still missing one important detail: their identity. To distinguish one pencil from another, manufacturers add information such as the brand name, product line, and hardness grade directly onto the surface. Using high-speed printing and stamping equipment, precise markings are applied to each pencil with remarkable accuracy. These markings are more than simple decoration. They help users identify important characteristics, such as whether a pencil is soft, hard, or designed for a specific purpose. Many pencils also receive decorative elements, including logos, metallic lettering, or special finishes that help them stand out in the marketplace. By the end of this stage, each pencil has received its final identity and can now be recognized by consumers around the world.
While many pencils are sold without erasers, some models receive additional components that make them even more convenient for everyday use. For these pencils, the next step is the installation of a small metal band known as a ferrule. This component is designed to securely hold the eraser in place. The ferrules are carefully attached to one end of the pencil using specialized high-speed manufacturing equipment. Once the ferrules have been installed, erasers are inserted and firmly crimped into position to ensure they remain secure during use. Every connection must be strong enough to withstand repeated writing, erasing, and sharpening throughout the life of the pencil. By the end of this stage, the pencils have gained one of their most recognizable features and are nearly ready for final inspection. Before any pencil can be shipped to stores, it must pass a series of quality inspections. Even a small defect can affect the writing experience and reduce the reliability of the finished product. Throughout the factory, both automated systems and trained inspectors examine the pencils for imperfections in shape, paint quality, printing accuracy, and overall appearance. The graphite core must also be properly centered inside the wood. If the core is misaligned, the pencil may break more easily during sharpening or use. Manufacturers regularly test samples from production batches to ensure they meet strict performance standards. Pencils that fail inspection are removed from the production line, while those that meet the required specifications continue to the next stage. This careful attention to quality helps ensure that every pencil reaching customers performs as expected from the very first stroke.